Please open your learning workbook to page 148. We're now going to complete several problems involving graphing a parabola when that parabola is given to us in standard form. All right, here's our first problem. Y equals 3x squared minus 30x plus 72. Notice the absence of parentheses here, which means we are not in vertex form. We are likely, therefore, in standard form, and indeed we are. Standard form is ax squared plus bx plus c. All right, so the first step here is to identify the values of a, b, and c. A is 3. B is negative 30. C is positive 72. Okay, so now we have to use these values to find our vertex. The formula for the x coordinate of the vertex is opposite b over 2a, which in this problem is opposite negative 30 over 2 times 3. A negative negative is a positive, so the numerator is 30. 2 times 3 is 6, and 30 divided by 6 is 5. So the vertex x is 5. Now we just have to find the y-coordinate that goes with it, which we do by plugging in. If x equals 5, then y equals 3 times 5 squared minus 30 times 5 plus 72. 5 squared is 25. Multiplication happens before addition or subtraction. So we've got a 75 here, a 150 here, and of course, 72. All right, 75 minus 150 is negative 75, plus 72 is negative 3. So our vertex is at 5, negative 3. Now we rely on our skills from the previous learning objective, and we put our vertex in the middle of an XY table. Our vertex is 5, negative 3. So, based on that, what are the other x values that we should use? Up by 1, down by 1, down by 1. Our x's will go from 3 to 7. Now we plug in each x one at a time. If x equals 3, then y equals 3 times 3 squared minus 30 times 3 plus 72. Exponents are first. 3 times 9 multiplication before addition or subtraction. 27 minus 90 plus 72. And if I wanted to put all my positives together, the 27 and the 72 make 99. Minus 90 leaves me 9. All right, next value. Let's do this one since we're expecting to get the same result. Let's do x is 7 next. If x equals 7, then y equals 3 parentheses 7 squared minus 30 times 7 plus 72. Y equals 3 times 49 minus 30 times 7 plus 72. All right, 3 times 49 is 147 minus 210 plus 72. Okay, the numbers are starting to get to be a bit on the big side, so I will reach for my calculator at this point. 147 minus 210 is negative 63, plus 72 is 9. same value. That gives me confidence that I've probably got both of those numbers correct. All right, so now I just have to try x is 4 and x is 6. If x equals 4, then y equals 3 times 4 squared minus 30 times 4 plus 72. Exponents come first. 4 squared is 16, so I have 3 times 16 minus 30 times 4 plus 72. Multiplication before anything else. 48 minus 120 plus 72. All right, so 48 and 72 combine to make 120. Minus 120 leaves 0. And that just leaves 6. If x equals 6, then y equals 3 times 6 squared minus 30 times 6 plus 72. 6 squared is 36. Multiplication before anything else. 36 times 3 is 108. (108) and 72 combine to make positive 180. Minus 180 leaves 0. Okay, there we go. We have our points, and our points give us the symmetry that we expect from parabolas. Therefore, we are confident that our numbers are probably correct. All right, let's create the graph of our parabola using these 5 points. I have a mixture of positives and negatives in the y's, but all of my x's are positive, so I need quadrants 1 and 4. 1, 2, 3, 4, 5, 6, 7 for my x's. 1, 2, down to negative 3. 1, 2, 3, 4, 5, 6, 7, 8, 9 for my y's. All right, let's plot some points. 3, 9, 4, 0, 5, negative 3, 6, 0, 7, 9. All right, there's the graph of our parabola. If the problem happened to ask for it, the vertical line through the vertex, which we call the axis of symmetry, is always x equals h. H for this problem is 5. So this is the vertical line x equals 5.